And this is one of my favorite courses, which I have taken large number of times. In spite of IBM courses, this is my favorite course also. And the thing I'm typing in the paint screen is visible, right?
Visible,
And
sir.
we can
Yes,
do
sir.
this. We will be typing here. Mostly, we'll be having some mathematical thing here compared to theory. What we'll be doing is we'll be having the paint screen as a board. I'll be doing all my writings and typings here. You can take screenshot. Whenever I run this, I'll be asking you to take screenshot, and you can have that screenshot, then paste it into your PPT or have like a document so that you can study later. Yes. Now, first what we are going to see is what actually we are going to study in the 5-unit syllabus, right? In first unit, what we are going to study is what is algorithms and what kind of algorithms are available. What is algorithms and what kind of algorithms available. So that's what we are going to see in first unit, right? What kind of algorithms they can do and what is algorithms. An introductory unit. Second comes the third and fourth comes the design strategies. You are actually in your class, many students or almost all the students are very well versed in programming languages, and some students when I then after post registration they have messaged me that I want them to teach the programming language also. So being a lab oriented subject, I'll be doing the Python stuff also here. Now I know that some students in your class are very well versed in programming languages also. For them also I'm saying, when you are approaching a program, you cannot directly write a program. You will get an output, but that will not be an efficient output. In this subject, you'll be learning how to do an efficient programming languages using design strategies. In previous programming subjects and all, what you will be doing is, you'll be having an algorithm part, but you'll be starting like start, include the packages, print, that's all, end. Like that you'll be writing, but that is not an algorithm. There is a design strategy that you can use. So what you're going to use here is greedy design strategy, greedy strategy. Actually, what is greedy? Everything you'll be learning. Very fun. You'll be understanding it very clearly. And if I was fast, if I was not able to deliver clearly, please stop me. Okay. One is greedy strategy and dynamic programming strategy. These strategies you'll be learning. Strategies of algorithms you'll be learning in second unit. Third unit comes backtracking strategy and branch and bound strategy. These two things you'll be studying in third unit. Finally, fourth unit, actually the end of strategical unit, what is you'll be learning is tractable and intractable problems. These things you'll be learning in final unit, tractable and intractable problems. Final is fifth unit. Well, before going to the fifth unit, I'll say what the importance of these units, then I'll come how the conclusion is going to be there, right? So first one, you'll be understanding the introduction of algorithms, then what kind of algorithms are available, how to solve those, what are difficult problems and what are easy problems, everything you'll be understanding in unit 1. You'll be having problems only. I'll make you crystal clear on how to solve those time complexities, space complexities, everything. You don't want to worry about it. I'll make you as clear as possible, right? Next comes the strategy, right? Why we use greedy strategy and dynamic programming strategy or backtracking branch and bound is, for each problem, if we use some strategy and solve it, we can solve it more efficiently. So if I solve it efficiently, then it means that I can use less time as well as less space in my computer. So that only I use strategies. So there are actually, you can ask me one question whether only 4 strategies are available in algorithms. Really not. We have many strategies available that I'll list separately. Here comes the strategies. But this is actually not according to your syllabus, but I'll just list what are the strategies available. Strategies of algorithms, algorithm design. So we have a basic strategy, that is brute force strategy. So what is brute force strategy is, for example, if I ask you a question, if I toss a coin, how many possibilities are there? Very good. 2 possibilities are here. One is head and another is tail. Now I am asking a somewhat different question. I tossed 2 coins, and what is the possibility of getting 2 tails?
1.
It can be head or head tail or tail head or tail tail. So what I can have 1 by 4. So like that I can form something, right? So if I was using some strategy, what I will be doing first, I'll go to first place. First place is actually saying me two heads, H and H. Second place is saying me H T. Third place says T H. Fourth place says T T. Now, to how many places I went, assume I was actually a CPU of the system and I was going and searching in first location, second location, third location, fourth location. So in the fourth location, I found TT, right? My answer was located in the fourth location. Now, this is called as brute force strategy where it takes all possible combinations. That is called as brute force strategy. One of the most accurate strategy is brute force strategy. And one more thing, since you are going to attend MCQs, these things, some words I'll be stressing a lot, so you can actually concentrate on those things. So what is the most accurate of all the strategies? That is brute force strategy. And the most worst strategy is also brute force strategy. Why I'm saying accurate as well as worst? Because you are checking all possible combinations for getting the result. So the result will be accurate, but will be getting lot amount of time to solve the same. Why? Because for checking whether there are two tails together, you are checking 4 times. Now, another person is coming and saying named as greedy strategy or dynamic programming strategy. This person says, I can find the two tails within two location search itself. Who says greedy or dynamic person comes and says, I can find within two searches itself. Next, a branch and bound will come and say, I'll find directly within one search, I'll be search and finding whether it is two tail or not. I don't want 4 searches. Like that. So if I increase the response time, that is, if I want to reduce that from 4 locations search to 1 location search, I need to go for strategies. I can use different strategies and solve the problem. That's where comes the strategies of algorithms. Brute force strategy accurate but takes more large amount of time. Right? We'll be having a detailed thing also, but this is just an introduction. Next comes divide and conquer strategy. By the name itself, it is very clear. When I face a huge army, and if I want to defeat them at once, it is very difficult for me. Otherwise, what I can do, I can divide them into shorter portions, and for each shorter portions, I can pose an attack, and then I can conquer the entire army. Right? That is what divide and conquer. We'll be seeing that, and I know that you guys have already done divide and conquer strategy in your programming in C paper and data structure paper also. Like you do merge sort, fix sort, and all, right. That and all will come in divide and conquer strategy only. I'll explain how it is coming also. Third comes greedy strategy. Greedy in the sense, what is the meaning of greedy? Greedy means I was very greedy. What is the meaning?
Wishing more.
Yes, I will not be satisfied. I want more and more and more. That is what greedy, right? So that is greedy strategy. That is also one of the strategy. That is next comes dynamic programming strategy. It is actually an extension of greedy strategy. Next comes dynamic programming strategy. Fifth comes backtracking strategy. Next example is how many of them know how to play chess? How many of them know how to play chess?
Yes, sir.
Yes, in chess, if I place a queen and I found that my queen is going to be attacked, what I will do, I'll take that queen and come back. We will go to one step back, undo. When we play with our brothers and all, we'll be doing like that, right? That is backtracking. I'll be doing some step, then I'll be coming back and say we will go to one step back because this is an attacking step. I don't want that attack. I'll be coming back to the previous position. Those is called as backtracking strategy. Next comes the extension of backtracking strategy, that is branch and bound strategy. And these are actually the most important algorithm design strategies available in the literature, right? So these things you'll be studying. Divide and conquer, it means that why we didn't include that in our syllabus. Why? Because we already have that in our programming in C paper also. I'll be explaining you how it is related also. These 3, 4, and 5, 6 will be studying in second and third unit with some example problems. So coming to the fourth unit, what we'll be studying here is we'll be studying something called as tractable and intractable problems. And if you see in the any syllabus, any foreign author syllabus, any foreign author books of algorithms, in the first page or second page, you will be having a statement. That is a common statement available in all algorithm books. What is that? Is all problems in real world are solvable. This is the common word available in all algorithm books. All problems are solvable using some algorithms. This is the word commonly available in all algorithm books. So, but according to the practical notation, we say that some problems are tractable, some problems are intractable. So what is tractable problem is? Tractable problem means those problems which can be solved in real time. Intractable means I cannot solve that problem in the real world. It is actually negative to what is said in theoretical book. Theoretical book says all problems are solvable, but practically we say some problems are not solvable. But why we can make it possible? How is we can go to some strategy called as randomization strategy and approximation strategy. If you are not able to get the right answer, at least get an approximate answer. That is actually the approximation and randomization strategy. Because some problems in real worlds are not solvable in real time. For those problems, we cannot leave that problems as unsolved and all. So what we have to do, we need to solve that problems. So what we will be doing, we'll be using some advanced strategies to solve those problems. Those strategies are called as randomization and approximation. Randomization and approximation strategy. So these 5 things only we are going to study in the entire syllabus of DAE. The introductory part in unit 1, greedy and dynamic programming strategy in second unit, backtracking and branch and bound in third, and tractable and intractable problems in fourth, and fifth comes the ultimate randomization and approximation strategy. For each unit, for example, if I take greedy strategy, I'll be giving you 2 to 3 examples. Like for greedy strategy, I'll be giving some job scheduling problem. Some problems will be there. We need to solve the problem. We need to find what is the time complexity and space complexity of the problem. Then we need to implement that problem using the strategy also. So these things we'll be doing for all the problems, right? So far, so good. Am I going well?
Yes, sir.
Yes. So going to our unit, algorithms. So what is the definition of algorithms? This is most important. Like when you go for a 2 mark question or an MCQ, it is a most important thing, right? So we'll be just seeing what is an algorithm, right? So now I'm asking to a question. For a particular program, what are its ingredients of a program? If I have a program, what are its ingredients? If I want to cook some idli, I will be having rice, I'll be having dal, I'll be having salt. Those are the ingredients, right? For a programming, for a particular program, and the name that you are going to do a factorial program, what will be its ingredient?
Variables.
Yes, what?
Main statement.
Variable.
First person said it correctly. It will be having some input. It will be having some input, right? It will be having some input. And to whom you will be giving the input? You will be giving the input to the programming language. And that programming language, it cannot be write directly. You should give that input to a person called as algorithm. You should give the input to the algorithm. Please bear with my handwriting. Whether it is understandable?
Yes, sir. Understandable.
Understand, sir.
Yes. And what will be the output? The next thing, output will come here, right? I'll be giving here output. So what will be the definition of algorithm is very simple. A set of unambiguous lines which takes a sequence of inputs and produces an output in a finite amount of time. That is actually called as algorithm. I'll write here. The words are very important here. What is that is? A sequence of unambiguous lines. What is the meaning of unambiguous? Takes a set of inputs and produces an output in a finite amount of time. So this is actually the definition of algorithm. So what is the unambiguous statement is which is most important for an algorithm. So what is unambiguous is unambiguous means non-confusing. The line should not be more complex. The line should not have any programming stuff. It should be in a very simple English. It should not have any programming stuff or syntax. It should be very clear. A sequence of unambiguous lines that takes a set of inputs and produces an output in a finite amount of time, right? So how this is actually possible in a real-time case? For example, if I have a huge amount of inputs, then what I have to do? You should give all the input in proper format, and the algorithm should run it, and the output should come. Another most important keyword here is finite amount of time. Many people say that I have done a program and I got the output. But those people, I say that though you get an output, it doesn't mean that you have done the program very correctly. You will be getting a correct, efficient program only when you solve a particular program efficiently. That is finite amount of time. For example, if Rushwant comes and says to me, "Sir, I solved a particular program in this much milliseconds for the particular input." Next, Murali comes and says to me, "Sir, I solved the same program in another less amount of time. It is the same amount of inputs." Then to whom I'll be going? I'll be going with Murali. Why? Because he solved it in even more less amount of time. So who will be winning is Murali. So the ultimate here is not the output. The ultimate here is the time. With who solves in who runs the program in small amount of time. It is not that who takes less amount of time to code. You can code her any amount of time, but the result when you are running the running time of the program should be very less, right? So this is with respect to the basic introduction of algorithms and algorithm definition, right? So the definition is very simple. An algorithm is sequence of unambiguous instruction for solving a problem that takes the set of inputs and provides an output in a finite amount of time, right? So what are the ingredients of the algorithm now? Can anyone say? What are the ingredients of an algorithm? So if it's like an MCQ, it will be very easy. Input, output, and should be solved in a finite amount of time, right? So if I'm asking, what about the algorithm? An algorithm will take an input, true or false?
True.
An algorithm will provide an output.
True.
And algorithm will provide output in infinite time.
False.
Yes, it will provide in finite amount of time.
True.
Yes.
True.
So an algorithm can have ambiguous statement.
False.
It should have unambiguous statement, that is non-confusing lines, right? Now it is very clear, right, how the definition of algorithm goes.
Yes, sir.
Yes. Now coming to the characteristics of algorithm, the same thing, if you understand the definition clearly, you itself can say what are the characteristics of an algorithm, right? So first characteristic is very simple, instructions. Instructions, the name is nothing but the lines of the algorithms. Instructions are not ambiguous, or you can say unambiguous, not ambiguous, or you can say it as unambiguous. The algorithm instruction should not be ambiguous. Algorithm instructions are not ambiguous. That is the first characteristic of an algorithm. Second characteristic, right? The range of inputs of an algorithm should be specified carefully. Right now, I will be asking you the question. You are asking to write a program to calculate age of a person. Right? You calculate the age of a person. Now I'm asking you. I'm the person. You are asking me what is an age through an input. Right? And in the console screen, you are asking. Shall I enter it as -6? As age, my age is -6. Shall I write that? And another thing is, can I write my age as 1023?
No, sir.
No. So what should be the proper range of the input? I can write from 1. 1 is the minimum age. A baby cannot come and say your input. So 1 is the minimum. Maximum can be some 120 or 130. That is actually the range of an input. So the second characteristic of an algorithm is the range of inputs. The range of inputs of algorithm should be carefully specified. If not carefully specified, what will happen? Some negative values for age, like that some inappropriate input will come into play, right? Third one is, this is more important, right? Now I'm asking you a question, right? For example, finding a factorial of a number. Can I, whether there is only one way to find a factorial or there are many ways? I'm asking in a programming language.
Many ways, sir.
I can use it for using while loop I can do. Using normal looping I can do. Yes, as he says, many ways. He correctly says many ways are available. I can use recursion to do. Many ways are available, right? So same algorithm can be represented in several different ways. Ultimate is finding factorial, that is 5 into 4 into 3 into 2 into 1 for an input 5. A looping can do, a recursion can do, even a looping for loop can do, while loop can do, many different things are there. So many different ways I can solve, right? Next, the fourth one is, this is actually the continuation of third one. For a same problem, several algorithms may exist. As I said first also, right? If Luchran and Murali are coming and saying me, sir, I solved the program and I got the output. Who got the output in small amount of time? That they'll be the winner, right? So many algorithms may exist, and who solves in small amount of time will be the winner. The algorithm that runs in small amount of time is the efficient algorithm. Not only time, small amount of time, and occupies less space is the efficient algorithm, right? Final one. So these four characteristics are very good and simple. Final one is algorithms for the same problem can be solved in different speeds. That's what I said. Algorithm for the same problem can be solved in different speeds. Different speeds in the sense I'm saying the time, different speeds. So this is what we are going to do, the characteristics of an algorithm. So what are the characteristics? Number one, algorithms are not ambiguous. Statement should be very clear, simple English, no programming syntax should be involved. Second one is the range of inputs should be specified very carefully. If not specified carefully, then you'll be getting an error. Third one, same algorithm can be represented in several different ways. Yes, I can use recursion, I can use queue, stack, graph, any data structure I can use and represent it in a different manner. Fourth one is, for the same problem, several different solutions can be there. By solutions, I mean the algorithms, right? Fifth one is, algorithm for the same problem can be solved in different speeds. So that's what I do. Right now, the thing is, now we need to prove that this characteristic is working or not working, right? So we will be going with a small example for understanding whether this characteristics of an algorithm is true or not, right? Yes. Now I am done with an algorithm and characteristics. Whether the definition is very clear and the characteristics is very clear, you should not forget this anymore if you learn here. So I'll say, if I ask definition, I'll say unambiguous set of inputs, set of outputs running in a finite amount of time. That is definition. What is the characteristics? The characteristics can be, what are those? Not ambiguous, input specific carefully. Third one is same algorithm, same problem can have different algorithms. Each algorithm runs in different speed, and so same algorithm can be represented in different ways, right? Am I making it clear?
Yes, sir.
Yes. So now you studied both the definition and characteristics, right? You need not refer it one more time. Am I right?
Sir.
Yes. Now, will you give me permission to delete this? Take screenshot. Shall I?
Yes, sir.
Yes. So now going with the proof of this characteristics. So what is the one of the characteristics says is for a same problem I can have different algorithm. Each algorithm runs in different speed and the efficient one we have to choose. That we need to understand with the basic problem, that is solving GCD. GCD of two numbers. Right. So what is GCD? Got it.
Greatest common
Yes,
divisor.
greatest common device. Now we are going to solve this GCD using three different algorithms, right? First algorithm what I'm going to use is Euclid's algorithm for finding GCD. This is what I'm going to use first. Euclid's algorithm for finding GCD of two numbers. It is go by a formula. First we'll be seeing how to solve the problem. Then I'll enumerate with the algorithm statement. Okay. First I'll say the formula. It is a recursive formula. Let us say finding GCD of M and N. That's what I'm going to find. So what I can do is, the formula is very simple. GCD of M comma N is equal to GCD of N comma M mod N. Right? Mod I can also write as this M modulus N. Right? So GCD of M comma N is equal to GCD of N comma M modulo N. Right? So now I'll explain this with numbers. I'll substitute some values for M and N. I'll explain it. Example 1. Right? GCD of what I can have 12 and 60, right? We will do this. Now you are going to help me in doing this, right? I'll be doing this GCD of 12 60 is equal to what?
GCD of 60
Right.
comma
60 comma
6 12 mod
12 modulo 60. Very good, very good, very good. 60 comma 12 modulo 60. Now before going to solve this, I'll be explaining you another thing. Very simple thing, hope everyone know, but let me explain one more time. What is 6 divided by 2?
remainder 0 question 3.
3.
How will be writing this? We'll be writing this 2 outside and we'll be writing 6 inside. How many times of 2 is 6?
3 times.
3 times. I'll be giving 6 here and I'll be putting the remainder as 0. Right? So what is this called as? The upper portion is actually called as, this is 6 divided by 2. The quotient. Quotient term is 6 divided by 2. What is this?
Reminder
Remainder.
6 modulo 2.
2.
I can write it as 6 modulo 2. Same thing, I'll be asking you another question. Same 6 divided by 4. Can you say me what will come here? I'll be writing 6 here, 4 here.
Question 1.
Question 1. Reminder.
Reminder. Very good, very good, very good. So what is 6 divided by 4? What is 6 divided by 4?
1.2.
6 modulo 4.
2.
6 modulo 4 is 2. Very good. So this is very clear now. Now final one, if you answer this also, you are expert. So I'll be putting a line here. It's a little rough one. So I'll be giving 5 divided by 7. I'll be writing 7 outside, 5 inside. How many times of 7 is 5?
0.
1.
0.
0. So what happens? I cannot put any number on the quotient. Why? Because the divisor is greater than the numerator. The denominator is greater than the numerator. So what I can do is the denominator is greater than the numerator. Then if you use division operator, the answer will be 0. Right? What will be the quotient? What will be the remainder? That is modulo operation. If denominator greater than the numerator, I'll be getting directly the numerator as the result. Right? Now understand this, how it is going on.
Yes, sir.
Yes. Now quickly say 4 mod 2. What will be the answer?
0.
0. 0.
Everyone.
1.
1.
What is 2 modulo 2?
1.
1.
2.
2.
4 2s are 8, remainder 2, so I'll put 2 here. Now coming to 3 modulo. What will be the answer?
3.
Why?
3. Sir.
Why? Denominator 5 is greater than the numerator 3. Denominator is greater than the numerator means the answer of modulo will be numerator directly. So I'll be citing another example, 4 modulo 7. Here also my denominator 7 is greater than the numerator, so I'll directly write 4. If I write 4 divided by 7, what will be the answer? Here also denominator is greater than the numerator, so I'll put 0. Right? Now it is very clear, right?
Yes, sir.
Yes. So these are all rough things. Now we'll be going to our problem directly. Solving this is equal to GCD of 60 will be like 60 only. There is no change. What is 12 modulo 60? Denominator 60 is greater than the numerator 12. So what will be the answer?
12 only.
Very good. Next, GCD of what will be the answer next? Here n is 60, n is 12. So how to change this? See the formula here.
GCD of n comma.
N is what? Here m becomes 60 and n becomes 12. Now interchange. Seriously 12 comma 60. Now it is 60 comma 12. So I'll write it as 12 comma
60 modulo 12.
modulo 12. So now we'll be solving this. It's equal to GCD of 12 60 modulo 12. So 12 ones of 12 is 12, 12 to 24, 12 into 3, 36, 12 into 4,
12 is
12 into 5 is 60. So 12 into 5 gives me 60. So what will be the remainder?
0.
12 5s are 60, remainder is 0, right? Remainder comes 0, am I right?
Yes, sir.
Yes. Now the stopping point, how many times I need to proceed this? If n becomes 0, return the m as GCD, right? If n becomes 0, return the m as GCD. So what is GCD of 60, 12 comma 60 now? My n becomes 0 and the corresponding m value at the time is 12. So my GCD becomes 12. Is it easy?
Yes, sir.
Yes.
Yes, sir.
Right. So this is actually the thing. Right. Shall I erase this particular portion, this rough portion? If you want to take screenshot, you can take. Shall I erase?
Yes, sir.
Yes. Thank you for giving permission. I'll erase this. Another short problem will be finishing with Euclid itself. Then we can finish off the class. The thing is, I'll be writing, going with this color itself. Example 2. We can say some value for m can be 25. M is equal to 25. And n is equal to, what can we have? 60. What second? Wow. Okay, I'll be having something like 16, some big problems. 16, 64. I think it is also not that much big. Let us check. Right. So this is the thing I'm having. Please help me how to solve. What is the formula? GCD of
GCD of m comma
is
n
equal to GCD of
GCD of N comma M modular.
GCD of n comma m mod n.
M modular.
GCD of
ఇక్కడ చూసిన ఎపిక్ నెంబర్
64 will be equal to GCD of
64 comma.
very good, very good. 64 comma 16 mod 64. Very good. Here denominator 64 is greater than the numerator. So again, what I'll do equal to GCD of
64 comma
16. Next step. Again,
GCD of
GCD of
16 comma
very good. 16 comma 64 mod 16. How many times of 60? How many times 64 is 16? GCD of
4 times and remainder 0.
16 comma 16 fours are 64.
Remainder 0.
64 64.
Yes, sir.
Yes, sir. Zero.
Remainder is 0. Now what? Whether I need to continue or that's all problem over.
Okay, that's all.
4, sir.
Yes. Then what is GCD?
16.
And so
16 comma 64 will be equal to 16. Right? Very good. This color. Let's show you solve this. Very simple, some simple problems, right? Now we can have any number of problems also. Now I'll give you one problem, right? Find the GCD of 32 comma 81. Sorry, 33 comma 81. GCD of 33 comma 81. Quickly, someone say the answer. 33 comma 81. So somebody can help me also. I'm typing here. GCD of 81 comma 33 comma 81. So this will be equal to GCD of
81 comma 33.
33. Next GCD of 81, sorry, 33 comma 81 mod 33. So now how many times of 33 is 81? 33 ones are 33. 33 2 66. 33 3 is 99. So I cannot go for 33 into 3. 33 into 2 is 66. 66 minus 66, 76, 81. So 15, right? Reminder, what is reminder?
15.
So 33 comma 15, right? Next up, equal to GCD of 15 comma 33 mod 15. This is very easy. 15 ones are 15, 15 twos are 30. 15 3 is 45. So I should not go for 3. 15 into 2 is 30. So remainder is 3. Very good. 15 comma 3. Now again going is equal to GCD of 3 comma 15 mod 3.
3.
So what will be the answer now?
3 comma 0.
3, 0.
3 comma
3
0.
comma 0.
I need to continue.
Enough,
So
sir.
GCD of 33 comma 81 is 3.
Is the problem over?
Sir.
Yes, sir.
So we will be putting in some other. Okay. Now GCD is very simple, right? Using Euclid's algorithm.
Yes, sir.
Yes, very good.